And we're streaming. All right. So everybody, welcome to MySec Jackson. Welcome to the new location that may or may not lose power here in a half second. We're not really sure. It's kind of unique. But this is going to be our permanent location from here on out. We won't be at our old place at all. So be sure if you're ever going to come again, it's always going to be here. Parking seems to be a little crazy. And we weren't expecting that because normally around this time, all these parking spaces are open. So there must be an event going on or something. I have. Every time I come here. Oh, Veritas is doing? Okay, yeah. So the restaurant next door is doing something. Normally these spots are open, or especially this Jackson Street right here. But yeah, not too many crazy announcements. Next. So for Converge, little announcements. We've got workshops are still open. Our call for papers is still open, so if you have a talk that you want to present on or a workshop you want to do, definitely hit up convergeconference.org and submit now. We also, yeah, those are really big too, actually. Our newsletter also just went on as well. If you guys haven't joined the newsletter, go to the mysec.us website, check out the newsletter. It's worth your time. We're plugging in every single security event that we can think of in the state of Michigan and putting it into one spot. So if there's something in your area or something else that you want to go to, we're trying to give you that opportunity. Otherwise, of course, join our Slack channel if you haven't already. And with that, I will turn it over. Zach?
So today we're going to be weaponizing autonomous vehicles. Hey! So before I begin, I just want to give a special thank you to the AMC from Ypsilanti, the American Mobility Center. They have a autonomous vehicle test track. They also do work with DARPA and a few other people, and the University of Michigan's Autonomous Vehicle Research Department. I've been in conversation with them on a lot of this stuff. Now I'm going to do my best to blow through the beginning of this, kind of the hardware, so we can get to the meat and the juices, which is the attacks, as much as I can, because the hardware, you need to know a little bit to attack, but it gets a little boring. And we're going to cover some stuff that should be pretty, if not interesting, should be funny. So real quick about me, my name is Zachary Stachlewitz. I'm a cybersecurity student here in Jackson. I'm a member of the Baker Cyber Defense team as well, and go to Baker of Jackson. I'm going a little fast purpose here just so I can get into the meat. So if you ever want to hit me up on Twitter, I can't promise I'll ever respond to you. It's at Raptor Binary, and in Slack is Binary Raptor. Don't ask me why it's switched. And the blog's a work in progress. So a little bit about me in this industry. I have actually worked in the autonomous vehicle industry as an intern. I've worked mostly on the authentication side of things, so how authentication between the vehicle's API and some of the hardware, and then between the cloud infrastructure. It's not anything really in-depth. It's just simple intern stuff. What's an OAuth token, bearer token? You'd be surprised how many people hard code bearer tokens in the crap. So we're going to go ahead and start off with this. Which of these two cars are autonomous? Anyone want to make a guess? Both? Both? Roll both? All right. Well, what if I said no? So a Tesla is actually what's referred to as a self-driving vehicle, where this vehicle on the right, which is a research vehicle, I can't remember the exact company, and I don't have glasses, so I can't see the exact name on there. That is actually an autonomous vehicle, and we're going to go over that in a second, in what's called an SAE layer, or an SAE level, which is a level of automation. By the way, my slides will be available. I do most of my talking outside the slide, and some of the information on the slide is just extra resources as well. So the Department of Transit sees 5 levels of autonomous. There's actually a 0, but we don't even count 0. Normally it just goes 1, 2, 3, 4, 5. Any vehicle that's truly autonomous starts at level 3 or level 4 to level 5. So at level 4, we have almost full autonomy. We're dealing with something around 70 to 80% autonomy. The car can make decisions on its own. The driver exists in case of absolute emergencies. Where Tesla sits at level 3, the car can make decisions on its own, sort of, but it requires a user for human interaction in case of moderate emergencies, and it often will put itself in cases where it needs user interaction more often. But most autonomous vehicles that we're going to be talking about operate in levels 4 to 5. 5 is full autonomy 100%. There is no need for user interaction. There should be a 0% level of fear that a human has to interact with. Should be is the key word there. As you'll see coming up here, most of these systems, SAE, level 4 and 5, there's a lot of fear. So here we have our levels of automation. As I said, there's level 0 to level 5. 0 is stick shift. No computer, nothing in there. And as we slowly work our way up, we're gaining more autonomy. As of right now, Tesla sits in this area right here because they do not have full autonomy. Yes, they can switch lanes, they can do integration. The car can make emergency maneuvers, but most of the time you're going to require a human element involved. All right, so let's dive into some of the technology that drives autonomous vehicles before we get into the meat and potatoes. This part may be a little bit boring. We're going to get into the fun stuff. So right here we have the Uber autonomous vehicle. Now what you're going to see here is the stuff to pay attention to is very simple. You want to pay attention to the top array, the front camera and sensors, and the back array. When you're looking at an autonomous vehicle, you want to think of 360 degrees because the car sees in 360 degrees. So some of the hardware, basically, we have cameras, Lidar. Is everyone here familiar with Lidar versus radar?
I don't know what it is.
So Lidar is a version of radar, but it's pretty much the next generation of laser mapping technology. Think of it that way, in a sense, where you have a laser. We're going to show here in a little infographic how it can map your environments, and it can also identify objects. It's much more efficient than radar. In some cases, there are companies who are making it in a smaller package. So as time goes on, it's often being a place taker for radar and also for lasers, depending on where your location is. If you live in the European countries or China, both of those countries are still kind of refusing to adjust to Lidar, where they're just using a combination of radar and a heavy sensor array to read distance between their environment in 360 degrees directions. I also want to note here, no company is the same right now. There is next to null standardization in the industry when it comes to autonomous vehicles. So take this talk with a grain of salt, because every company has their own way of doing things. They may use Lidar and cameras but not use radar. They may use special in-house software packages. They may use payloads and external systems that aren't used in other companies. So it's just, you have to be very careful when you talk about autonomous vehicles because nothing is the same. Everything is different. Some cars that are called autonomous vehicles are even driven by an RC remote controller. Sadly, that does count as autonomy level 4, but we're going to go with it. We have satellite receivers and transmitter. I want to make that clear. Most of the time, you only see one transmitter and several receivers because you have to guarantee that when a car goes down an alleyway in a large city, it's gaining a good coefficient of satellite access, because most of the time you'll see with some of these data relays, they're working with Wi-Fi, satellites, RFID. You have your RFID, perfect transit. You have receivers and transmitters for something I'm going to get into later for the communication protocols. Lasers and lots of lasers. Everything is built on a laser of some shape or form because you have to have an efficient way of telling what is the distance between point A and point B. How far am I from car A to car C? If I'm driving and there's a pedestrian crossing, where is the pedestrian moving in relation to the vehicle in distance? It's all math. We have Wi-Fi access points, ultrasonic readers, and like I said, some cars will have new things, some cars won't. It just kind of shifts around, changes. So let's talk about cameras real quick. Here's an example of the Uber camera array. In this case, we're dealing with a control computer here to your PC. All of the cameras are supposed to be set up in an order in which they're 360 degrees of vision, somehow, some way, and then there will be more. I have more on this when we talk software in relation to imaging and how you can use hitbox imaging. And there is fracturing in hitbox imaging, and there is a relation between hitbox imaging and IVP6. That'll be pretty interesting. Here's Lidar. Lidar works in the same way as radar does, except for it uses lasers a lot of the time, where you have it sitting on top of a vehicle. I mean, we've all seen an autonomous vehicle, right? Okay, well, on top of it, there's that big alien radar dish that's just scanning around. Well, that's Lidar. Also, when you look around, you have Lidar in the front here, and you'll often have Lidar in the side and the back. It is the most efficient way to 3D map your surroundings without cameras. And then we have lasers. This is a simple laser you can use for distance reading. There's not much that's too advanced to this. It's just point A to point B. How far am I? So this is a autonomous company called Waymo. Can anyone tell me where the computer is in this car? I can promise you, you're looking at it in a way. You want to take a guess? Yes. So Waymo does something pretty interesting where there is the equivalent of probably, I would say, 3 to 4 slices, server slices, in the top of this vehicle, all water-cooled, by the way. All water-cooled. It's crazy. And also in this component is also where all the hardware communicates to a correlation system, because all your images have to be correlated, all of your laser data has to be correlated. But yeah, every vehicle this way has a computer on board and a computer off board. I want you to remember that. There's computers on board the vehicle and there's computers off board the vehicle that are all involved in what's called the prediction data.
Zach, with all of this laser stuff and not knowing much, is there any danger to pedestrians?
We're going to get into that.
Okay.
Yep, we're going to get into that once we get done with some hardware and how you can manipulate some of these hardware components without doing anything technical. And how you can also manipulate them using fragments, sort of like you see artifacts in a movie or a video. Well, artifacts is killer to a car because it doesn't know what's in front. So let's talk about software. Now this is the part I wish I could bring in some software and show you. No one, and I mean no one, would let me anywhere near them. So the reason I can't go too deep into software is that everything is done mostly in-house. Everybody has their own way of doing things. Everybody has their own way of building applications, imaging software, cloud-based resources, AI predictions. It's all done in-house. Normally, there is some outsourcing to separate companies, but everything is done in-house and it's kept under tight wraps, unless you're a business giving a marketing meeting and you show your source code in the PowerPoint, which I actually saw happen. So visualization is one of the key components of autonomous vehicles. We'll go into that a little bit more in depth. Mapping and geomapping, so this is kind of an external factor. We're dealing with a combination of Google Maps. We're kind of dealing with a combination of onboard data and local mapping. This could also revolve around your Lidar. Most of your sensors are feeding data to multiple components. Visualization is different than virtualization. Visualization. Yeah, that was a trick there. That was a social engineering attempt. So virtualization, as we saw in the Waymo vehicle, you have a lot of computing power on top of this car. And you can, how do we best optimize this? We virtualize it. Because we're going to have, in most cases, little computers running one piece of software, it's running another piece of software to another piece of software, or we could be running a cluster sort of computing array. Image boxing, which is different from visualization because image boxing relies on a whole different suite of software and has its own suite of problems. But a majority of cars do use image boxing. We're going to see some examples of it coming up here in a little bit. And as I said, most of the software is done in-house. Now we also have to communicate real quick on how do vehicles talk. Not every company, again I have to note this, not every company, there's no real streamlined standards. Not every company follows every single communication protocol. Some may not do vehicle to pedestrian. This is a quick little infographic. We're going to go into depth to the ones that are important. So V2V, or vehicle-to-vehicle communication, is where you have an autonomous vehicle and an autonomous vehicle, and in some cases an autonomous vehicle and a non-autonomous vehicle, communicating. My location is at 86 degrees north, south degrees west. I've just sent a pedestrian to my right, relay it to car B, and then they'll talk. This allows it to help the prediction systems to lower the risk of an accident. We're going to use the word accident here a little bit more coming up. Sadly, one thing that's sad is that a lot of this vehicle-to-vehicle data, some of it does use UDP. It is throw and forget data. They are switching, and I have seen some that are switching firsthand, but a lot of this data is throw and forget, which is concerning because some of these cars don't get the relay data. So say this car here didn't get a relay data, that this car just sensed a motorcycle, and it would make the turn anyway. So some actually states here are pushing for laws to make it so vehicles that are not autonomous will have vehicle-to-vehicle communication. And you'll see that coming up again with vehicle-to-grid communication. I'm going to burn through this a little quick again, like I said, so we can get to the meat and potatoes. Vehicle-to-pedestrian data is kind of like vehicle-to-vehicle, except for your pedestrian is the one communicating to the vehicle. Everyone here has a smartphone, I would assume. That smartphone is capable of transmitting GPS data. That's all you need. And when you have GPS data, that's all you got to do is tell the car, hey, this is my location, please don't hit me. I'm begging you. That can also be toyed with pretty bad because often that data then goes to a cloud resource and then to the vehicle. The vehicle itself, when it comes to vehicle to pedestrian, often does not do the calculations on board. It waits for off-board data to be onboarded. The other hand is I want to note here, different satellites will bring back different GPS data. And we're going to get into that a little more and how a what is the European satellite? Is the geosynchronous, the European satellites are different from your American satellites, and how you can use that to manipulate GPS data. This is something that's being developed, by the way, but it's being developed very slowly. And for pedestrian safety, it's probably one of the biggest things in the world. I actually worked on a system while I was interning firsthand that was vehicle to pedestrian. And it is extremely important for the communication and the safety of pedestrians because it does not rely on just hardware. It relies on a combination of a hardware failsafe and a software failsafe. So then we have vehicles and network. There's networks everywhere. When we talk about network, we're not talking about swinging by Starbucks and picking up on their access point. Instead, we're talking about, in this case, Wi-Fi signals that are set up by the smart infrastructure or smart cities. I'm sure most of you have heard of smart city projects. I know Ann Arbor's pushing for a smart city project where they're installing 4G and Wi-Fi receivers at intersections on top of stoplights, pedestrian transmission devices, and other systems. The goal here, though, is to be able to communicate with the grid. Not the grid, but the network. So cars can communicate to other cars that are nowhere near it. Cars can communicate information on car data, car statistics. And I'm not going to read over everything. My slides will be available if anyone wants them. But this is a component that has to be built into, should be built into, with vehicle-to-vehicle communication. And as I said, it relies on 4G. If anyone tells you their autonomous vehicle relies on 4G, they're lying to you. Almost every autonomous system I've ever seen and the devs I've talked to only relies on 5G. It depends, but most of the systems are almost all 5G. And I don't know about you all, but I don't see a 5G network everywhere, which is concerning because some places are testing using 5G and not 4G. And then there's satellite. Depending on your kind of satellite communication, that's where you also do have GPS data. There's a ton of data being transmitted from these vehicles, a ton of data. Okay. Then we have vehicle to infrastructure. This piece right here, along with, I don't believe I talked about vehicle to grid. No, I don't. So I want to talk real quickly about vehicle to grid. Grid is just pretty much your power network. I like to think of vehicle to grid as a component of vehicle to infrastructure because the grid is just a component of infrastructure. But with vehicle to infrastructure, this is where we talk about smart cities. We have systems that are relaying data from pedestrian systems. So if I hit the crosswalk, it'll relay to the autonomous vehicle, hey, there's a pedestrian waiting to walk. Maybe you should stop. The lights have just turned green at intersection B ahead. Stop, please. There's cars broken down in area C relayed to a stoplight that's then relayed to a vehicle. The one thing I want to make extremely clear here is there is data passing for everything when it comes to these sort of communication networks. Cars are talking to cars that don't even need to know things. Data is going through components that don't even need to know things. So we're dealing with a lot of data crossover here, and we're dealing with a lot of possible data leakage risks down the line when we expand the surface. And you could even say we're expanding an attack surface here. So this, when you look at this graph, I want you to just get rid of don't look down here right now. Look up here. So we have a satellite communications. Which is our GPS data, some transmitted data otherwise. We have our vehicle-to-vehicle communication and our infrastructure communication. Now you notice this is missing something. And this is missing vehicle-to-pedestrian data because a lot of companies don't care. Remember, if you get hit by the car, it's not their fault, it's the car fault. But think of it this way, that all the data is correlated. It's thrown together into some service. It could be an AWS computing cluster. It could be local to the vehicle. It could be a number of things. Often what you'll see here is you can throw this out of the way and you can look at how dot domains work, where you will begin giving data to one domain, that domain will drop down to another, and then it'll split down, and you'll slowly start to trickle down what you need exactly. And then we have a better example here where we have a vehicle to infrastructure. Vehicle to pedestrian, vehicle to homes, which is a Tesla thing. Don't ask me why. Everything has to be smart home. Vehicle to grid. Vehicle to home is a thing that Tesla's pushing really hard, mostly because they're also trying to sell you their smart home technology. I can't remember what it's called, their solar panels, along with their charging arrays. Yep. And that's where the vehicle to home is, because then you can see if I pull in at 10 o'clock and I'm done, how much charge I have in my battery when I'm done charging beforehand. It's rudimentary data, but it's not something that right now, true autonomous vehicles care about. Then we have our vehicle to pedestrian. For some reason, this guy's blind. And we have our vehicle to vehicle, our vehicle infrastructure. It's pretty simple in the fact that, think of it this way, everything has to communicate like in a network. Some things shouldn't communicate, so we segment it. And some things will have to communicate no matter what for this to work properly. We're going to get into it a little more here about why vehicle to infrastructure and vehicle to vehicle are almost going to have to be connected in a symbiotic relationship, or we're going to run into some interesting problems. So before I get into, I had to get one pun in here, so let's get pawing. So before I get into the meat and potatoes here, do we kind of, any questions about hardware, software, and the infrastructure stuff? Yeah, go ahead.
I'm just curious, if you're using a camera system, or LiDAR system, or something like that, I don't know a whole lot about LiDAR, but I know enough about the camera system, but what if like somebody's going down the expressway with one of these, and there's some dude standing beside the road, you know, some jackass with a laser pointer, and just shines the camera across it, is it just going to right into a brick, you know, right to the center?
Don't drive a Tesla down that highway. We're going to get into that, trust me. Yeah, without giving away too much, yeah, both autonomous vehicles and self-driving vehicles are extremely vulnerable to imaging systems and fake images. We're also going to talk a little bit about fracturing, how different kinds of imaging software can fracture, and how you can use the fractures to pretty much crash the car. Software-wise, not hardware-wise. You could use it to crash the car hardware-wise if the developers did a horrible job. Anything else?
Why UDP over TCP?
It's easy.
Okay.
So before we end up here,
Figure they need the robust error checking.
some do. I have to give some companies a pat in the back where they do take security very seriously. I do end this talk off by talking about why software as a service, which is what most of these companies are doing right now. They're also treating cars as infrastructure as a service. How that creates some of the vulnerabilities we're in, and that has to deal with a relationship between business and development, where business wants one thing, development wants one thing, but business is often going to take command, and business is going to say, I don't care if you need another month or so. I need this yesterday. So make it happen. We're also going to cover how some of these companies are making money off of data and not on vehicles themselves. That's also a component of software as a service and infrastructure as a service. The more that they need to expand, we'll get into that. Did you have something?
Oh, wait.
Okay. So yeah, let's get pawing. I had to get my one pun in. So the first law of cybersecurity states, if there isn't a vulnerability for it, there will be. This stands for cars as well next to anything. So again, I want to quickly pre-note that the weakest component of any cars, including autonomous and not autonomous, is the endpoint components. So we have USB access points. If you want to get into a car really fast, you hit the USB port. There's 90 to 8% of the time, the internal USB ports have no security at all. There is no internal checking at all of it. So you can hit that internal USB port, bypass straight into the control computer, and then God knows where you can go from there.
By internal USB port, do you mean the USB port in the car?
Yep, internal USB. So you could have a charging port,
Okay.
and then you can use that to, there are some cars, some of the more fancier ones like Tesla, I mean, they have internal checking sensors and stuff, but I believe, if I remember correctly, those use a Tesla-made.
Yes, you're not talking about something under the hood.
You can, yes, so you can go under the hood.
You're talking about the USB in the cabin?
Yeah, you can actually take the USB in the cabin and use that to access the control computer. But you can get under the hood as well and do some hardware stuff. It's just, You have to know a little bit more depending on the vehicle. So like the older the vehicle is, if it has a control computer, you can still get into it, but you're going to have to know how to electrical engineer. It depends. Most of the time when I'm talking about endpoint devices, I'm talking about USB, Wi-Fi, RFID, as cars integrate RFID into their checking situations. But think of USB internally and externally. Tesla, if I'm correct, does have an external USB connector, though it uses their proprietary ports. But we all know how easy it is to hop on probably eBay and find a bypass. Did that solve that one? Yeah. Okay. We're going to get into a little more how you can do some of the internal stuff. As we add more autonomous vehicles and we add more components to our grid and our infrastructure, I'm going to use quotations there because the grid and the infrastructure is what is our pedestrian system, stoplights, road sensors. We create more nodes in a network, which we increase our attack surface, which makes it easier for a threat actor to, dare I say, pivot using special means. Let's see. And as I said before, there's a heavy lack of cybersecurity. I had the opportunity to attend a autonomous vehicle summit. I'm really happy I did, but I met some people that made me want to rip my hair out. And this is a quote I got from a dev. I was told the technology is more important than how we secure it. How we secure it is. We have to get things working and tested and then deal with the security in the future. I almost fell down the stairs, and there wasn't any stairs. That wasn't that bad, though. When I talked to a business guy, this was the next thing I was told. The autonomous vehicle industry is fairly new, so the risks are low. Luckily, I hope he's not in the security team. I can only hope. And we'll get into that as in a little bit later in software as a service. But there was some dumb stuff I was told. And if we want to talk later after this, there is some even dumber stuff. And sadly, a lot of it comes from head devs and marketing professionals because they're the ones who are selling the products. They're the ones who often have the relationship between the customer and the consumer base. So let's get into the meat and potatoes. Attack 1, spoofing pedestrian data. If you guys are interested, I'm also working on write-ups. I have proof of concepts for everything. Sadly, my demo broke. I had a demo for free of my attacks I'm going to show you. It broke, but if you're interested in seeing it, let me know. I can get it to you. I can send you a video of it. It's just a bunch of Python scripts thrown together that pretty much makes an autonomous vehicle work in a simulated environment, and we can do some stupid stuff. And I do have a write-up. I'm working on write-ups for every single one of these attacks, and I'm also working on more realistic proof of concepts. Spoofing pedestrian data. This is the one that's one of my favorites because no one thinks about it, but cars are starting to use pedestrian data from GPS devices from our phones, and then it doesn't transmit directly to the vehicle, which means there's a lot of leeway between where the data goes from point A to point B to point C. And every hop it takes, it has to go through something else. There's always a risk you can catch it at one point and interject something different. Or you can do something as simple as download the application on your device, just spoof your data. Or, as I found out, make a virtual phone, download the application on the device, spoof the data on the road, make another virtual phone, spoof that data next to the car after it's stopped, and the car's dead in the water. Because as far as it's concerned, now there's 13 people surrounding it. And that is a concern that does have to be addressed, is that there is little next to no checking to these pedestrian applications that are mobile. So this will depend on several factors. So spoofing pedestrian data becomes harder depending on how many layers there are, what is the AI integration involved, what is the machine learning involved, is there actually a check and monitoring solution in place, and did they actually authenticate the connection? You'd be surprised how many of these systems are not authenticated properly. I saw an example where they had a user device, they had a web application, and it had a hard-coded bearer token in it for OAuth 2. So it practically bypassed the OAuth 2 because you already hard-coded every time it ran, it would give you a new bearer token and hard-coded it into the script. So there was no even need for the OAuth 2 authentication. And if you were to get your hands on the initial source code and you were to unfuzz it or you were to unobfuscate it, you could have a world of fun because now you have the script to pull down bearer tokens as you wish. So what we're going to be dealing with here is targeting the API, the post and the get data is where I found the most success. Most of the time we're going to be dealing with JSON formats here. Everyone's familiar with JSON, right? Awesome. So here is an example of a human readable JSON. It's not that garbly gunk that you get when you first do like a GET request or a pull request. We've seen the garbly gunk version for the most part. Okay. This is an example. Normally you would have your user ID data, you would have your serial number, some junk here and there. Then once we get down, here's where the good, juicy information is, the stuff that you want to focus on. You're going to be dealing with three main things. You're going to be dealing with your latitude and longitude, which is often grouped as one component. Altitude, sea level, which is going to come back to bite them in the butt for having that, and positioning north, south, east, and west. Depending on how advanced the system is, you can even get a forward positioning data where you're seeing, if I take a few more steps forward, what is the direction I'm heading in? And it'll tell you a little bit of a precondition, what it thinks is happening. Most of the time, I want to pretense, most of the prediction is done behind the scenes by an algorithm after the JSON's been passed. And we're going to also talk about that because that system is separate from the vehicle, but the data still has to transmit to the vehicle. So here's an API cloud map, or an API cloud map. Most of the time, we're going to be working with, if you're going to be doing this, you're going to be working with an IoT map layer. So a function of the JSON API call, some APIs are called something different. But you also see this is a vehicle layer, so that's why it doesn't have to pin every second. With pedestrians, you have to be pinning a lot, and you have to be pinning very rapidly. I got to speed it up here a little bit because it's 41. So what we can do is we can intercept the JSON, or we can send fake JSON. By modifying your GPS coordinates simply just by spoofing the device, you can do a lot of damage. But if you can get your hands on the JSON, then you can create whatever you want. You can then create a situation where you're now below sea level and the car is confused beyond all belief. I also ran into a bug where if you were to switch the satellite types mid-JSON, so if the system's calculated to receive European satellites, which for some reason most of these systems are in US soil, don't ask me why, I wish I could tell you, and you were to change it to a USA or a RSA or Russia or US satellite system, it could throw the car for a complete loop and it'll stop most of the time due to its fail-safes. Let's see here. So the key behind this attack for me, I had a demo where I had a pedestrian had a device. We virtualized the device and spoofed the data. And then we also were inserting JSON data that was fake, where we had a change in the GPS system, and we had a change in the altitude and the depth, which for some reason can throw a car off heavily, because if the car thinks you're below it, it thinks it killed you. So it thinks it already made a mistake, so I better stop. So let me go over this real quick. This is really cool. It's from a research study. This is during rush hour at 5 o'clock. No cars are hacked in the first image. In the second image, 10 cars are hacked. You can see the light is the congestion. As the light goes away, you start to see darkness is more congestion. And we get into this purpley congested area here where we're dealing with about everything shut down. This is an example of how if you were to stop a car, you could shut down the city of Manhattan in hours by properly shutting down the right cars at the right spots. So pedestrian data, we have more on that. If you guys are interested in seeing a demo, please let me know. I will try to get it to you. I wish I had a little bit more time, but I don't, so I'm going to move on here. Okay, is it all right if I go over a little bit? Oh, sweet. Okay, forget it. Then I can go over a little more here. So my goal here when I did this was to then inject the JSON data back into a cloud format. So the way it was set up was it would hit a cloud format first and then be calculated into prediction data. I want you to keep the word prediction data in your mind because it's going to come back to bite the cars in the butt later. But the prediction data is pretty simple in the fact that I need to send where my user is and where it's going. Because the car is going to calculate where everything is going on top of where it's going. And if it thinks that there's a pedestrian going to enter its area, it'll stop. Even if the pedestrian is walking, so I had it set up where the pedestrian was walking down the road, and this is all virtualized. And I would always say, turn right. Make it think you're turning right into the street. So the car next to it would stop. The data would continue, stop, stop, stop. because it keeps thinking that that the guy's going to walk out on the road, so it's trying to preemptively stop an incident. Or an accident, we'll rephrase. And you can do the same thing with bicycles, you name it. What'll be interesting is I know with Ann Arbor especially, they're deploying these little robots around Ann Arbor. I can't wait to see some of the nightmare fuel that comes out from that, because these things are small enough that it could possibly not be registered on the hardware side of things, and it's not going to be registered in the software side of things. But if it picks it up using GPS data, who knows what the car is going to do? Because these things are sporadic. The other thing is attack the car sporadic data. The more sporadic the data is and the harder it is to compute, the more problems the car will have. In one case, I actually crashed the application when doing one of these attacks, because I threw an entire library of GPS coordinates at one time. I'm like, here, have a dictionary. I'm going to take one step, but I'm actually walking 4 miles. Well, the car's sitting there going, okay, I understand. You walked here, you're here. Where'd you go? A few times it'd be like, okay, I don't care, I'm going. Hope you're not there. And the other times you'd be like, I'm waiting. I'm waiting till the final walk data. So it would just sit there. And it would sit there until all the pedestrian data went through. And then sometimes, because I sent it in lump sum, it would hit the processing server. The processing server said, can't do it, drop it. So it would just say, I don't want it. Now that could have been the way I configured No, people don't just disappear, people don't teleport. I'm not that dumb. But if you were to pinpoint it every second or every 0.5 seconds, then you would make the car go, okay, that guy walked. But I know he's in there, so I better not move. Did that explain it all? Or?
Yeah.
Okay. It's kind of hard because you have to do some manipulation with a combination to kind of bypass the part where the computer is trying to guess where the human is going to go and what it's going to do. You have to understand the relationship between the satellite type and the Json type. Because I'm going to go into here in a little bit here, but I was actually able to crash my entire autonomous vehicle virtualization system by switching the satellites from the European satellites to the Russian satellites to the American satellites, because the data transmission types was confused.
Did you ever run into anything where you gave it some spoofing data and instead of stopping or just keep going, it did something sporadic like, I'm going to pull a U?
Yes, I had it where I had a pedestrian spoofing data on the sidewalk. It didn't know the pedestrian was there because he wasn't sending his data, so it hit him in an attempt to avoid the fake people. Yeah, there's some interesting stuff you can do. Oh yeah. Okay.
Just kind of curious things. You talk about a lot of the dangers of a car being networked to other vehicles and the different way threat actors get to it, and that way a vehicle could work completely off the grid and not connected to anything else? Is that the long-term goal? Is that the foreseeable potential?
It's the idea. So some companies would like to see that in the future, but some companies do not want that actually. They want to have systems that are segmented from the vehicle so that they can push their AI generations easier. They also rely on training the AI separate from the vehicle. Some companies, unlike Waymo, don't have the processing power on board to support the vehicles. And they don't believe in a business model that wants the vehicles to have the ability to do their own self-computing. It's a company thing. It's kind of weird because some businesses are for it, some aren't. I can't tell you firsthand. It would be something we have to look at. And like,
What direction do you feel like the industry is kind of leaning towards that? Is they exploring everything, or is it industry?
they're leading towards cloud solutions. Cloud solutions almost 80%, because they can then off-source from a company, for example, pedestrian data from a prediction server in the cloud instead of having to do all that work on their own systems. Sadly, and another thing is, like in security, when we add more pipes and more tunnels, that's more we have to harden, that's more that we have to maintain. And that's more that's in transit. And data in transit, in some ways, is at its most vulnerable state.
Well then, so you have this vehicle that you can, drive.
Yeah.
What about like a physical kill switch in the vehicle? So say you're stuck in
Yeah.
traffic, your vehicle's been killed along with 1,300
Yeah.
other people.
Yep.
A physical kill switch that automatically switches it over to human interaction.
Yep.
To where all of a sudden the AI is turned off and it's just strictly a dumb vehicle.
Yeah.
Is that something people can be doing, or is that?
I think, so if you look at some of the buses, like in Ann Arbor right now, in U of M, not WCC.
Bus like holds a bunch of people, or bus like a CAN bus?
Bus, like an actual, they have autonomous vehicles right now running on the U of M infrastructure where they do have kill switches on board. I think that the future, personally, in my own opinion, you have to have a kill switch. I mean, safety will have to be the utmost priority for the people riding in the vehicle, because there are going to be instances where the vehicle is going to do something stupid no matter what.
You also run into a problem. So, say they include the kill switch.
And then people just, yep.
To use autonomous vehicles.
Yep.
And
It's kind of like on a bus.
as time goes, people forget how to drive.
Yep.
We already have that problem.
Scripting and
Well,
computers, as soon as your script fails, a lot of people struggle with getting back up off the ground. It's like, script's dead. What do I do? And it's just power.
so yeah, we can. I'm gonna move on here, but we can come back to that real quick because I got some more in a minute. But I want to try to get through this. So this is another attack today where it's data injections. Again, a lot of these attacks revolve around attacking the API because there's so many APIs involved in autonomous vehicles, and oftentimes you're dealing with one API for this, one API for this data. So then I got this idea. What if we just start man-in-the-middle injecting data? What if we just start manipulating data? What if we treat it like an SQL injection? But then the more I dug into it, the more I started thinking, people can inject data into a VR simulation. Oh, that's going to be some fun stuff. People can inject data into VR. Do we know about some of the VR attacks where you can inject like fake environment data? You can turn off the safety for your environment. We can almost do the same thing for vehicles. Now, this is where your laser pointer comment comes in. So a research study done in Israel took a drone with a $20 projector and a $10 laser pointer and caused several incidents where they were projecting people onto the road. Well, as far as the vehicles were concerned, those are real people. Then, on the other hand, they took a laser and they took the stop sign and they made it a soup sign. It was a soup. It was so they got rid of the T. So they shined the laser on the sign, and then they made it so the car couldn't read the sign. So then you have a fake intersection, and you have this vehicle sitting there. It's going, I don't know what soup is. Right through it. So then they thought, let's take this one step further. Let's make a fake speed sign. What is the fastest we can go? So let me go over here real fast. So then we have people with projectors now. So this is an actual Tesla vehicle, and this does work for autonomous vehicles as well, but I do have to pick on Tesla here. As far as the vehicle is concerned, this guy's laid out flat in the road. There's a pedestrian in my way, better stop. Pedestrian safety protocols are first. Stop the car. So it stops the car. So self-driving, I don't know what the speed is unless I read the road sign, because Tesla works mostly on cameras. So when it sees that the road sign is 90 miles an hour, it goes, let's go 90. So then it turns the car into a speed machine, and it goes super fast. This was actually another interesting one where this guy put a projector in the front of his car and randomly turned it on, and the car was slamming the brakes. I was like, there's a car in front of me now. And I was waiting for it to. And then you can also manipulate stuff using positioning data like this. But this is something I was thinking about. If we can trick a car into doing this, all I have to do is then spoof data into the cameras. All I have to do is then spoof data into the because the application I was using allows you to put fake and like inflatable vehicles and things.
This is not picking up.
Oh, okay.
Pretty good.
Okay. So it allows you to put like fake things in the road. So I put like a fake person in the road, a fake things in the road. Then I got the idea, what if I could spoof image data into the image processing? If I could make the car think this sees a person, but there isn't, it's going to stop. So then there comes to a few problems where you have to attack the car's engine. You have to attack the car's data center itself. It's an attack that relies on a lot more sophisticated understanding of the system. This attack I would not be able to do in the native environment if it wasn't for me understanding how the system talks and correlates. It took a black box test and flipped it upside down. I would not be able to do it if I didn't have my hands in the pot. To say at least. If I didn't have my hands inside the scripts and I didn't know how it communicated, and I didn't have a direct interaction with how these vehicles talked, then that would be a little bit different. But yeah, you can see we have a guy in a suit thinks there's a car. We have a fake stop sign, or a 90 mile per hour speed limit in what looks like just a city road. So that should be interesting. But what the Israelis started doing were they were throwing projectors and lasers on drones, having the drone go in front of the car, blocking out stop signs, speed signs, so it would enter at 25 and it'd be going like 90. But the idea behind this attack was to inject data, and what I wanted to do was target this, what this image here. So this is what some of the cameras in the car will see. And you see we have a hitbox detection. That's what all these boxes are. We have a detection on people, stoplights. It even detects that it's a green light. And my goal here was, what if I could spoof in fake data? What if I could trick the car into believing there's a person here there isn't? I was able to do it only with the ability to do a direct man-in-the-middle attack. It was the only way I could inject something in the application. But when I did inject something in the application, at any point in time, I could just hit a keystroke and things would appear. And it would either stop, it would go faster, or manipulate data. And the other thing I played around with was, what if I poisoned the records for Google Maps for it? What if I manipulated the data for its mapping resource? So Google Maps stores data on speeds and traffic, data. So when you get Google Maps on your phone, you can actually see if you're going 55 miles an hour in a 35. So I thought, let's poison that data. Let's tell it, let's say you're on a bridge, turn right now. So if you trick the sensors into thinking everything's okay, and you kill the safety link between the sensors, again, I could only do this with my hands in the pot. When I killed the safety link in the sensors, it drove off the Mackinac Bridge. But because it believed it was at a turn in the middle of Ann Arbor. So that's something interesting. Now, another thing I want to note on, this is a problem with image hitbox detection, is that there's something called fracturing or artifacting. There we go. So you see how there's these, in each frame there's the box. So what happens in this style here, and this is the biggest problem of some of the hitboxing technology, is you can't actually do hitbox detection frame by frame. If you do it frame by frame, you're going to create artifacts. And those artifacts will negatively impact driving performance, detection rates, all sorts of things. And then you're going to start dealing with artificial fake cars. It'll think that the car's here when it's here. And you can see, so this is wonderful because you can see the artifacting. You can see where it's chaining along And you can also see where it's picking up road data and everything. You'll even see it artifacting on things that don't make any sense. Where is it? Right there, artifact. So it's artifacting on what it thinks is a sign, but it's not a sign. But because there's an artifact there, the car is still going to process it, even if it doesn't have to. And there's two problems here. It's going to waste data. It's going to waste data processing time. And it's going to waste precious time that this car has to make decisions in a matter of seconds. And that's something that is not always thought about in this industry. There's also a problem I was informed of that IVP6 is the only way to do data transmission like this, because you have to send in such a data stream where you're monitoring more than just the frames. I can talk more about this later, but that's another component where you want to look into how can you manipulate the artifacting, because if you can manipulate the artifacting, you can possibly stop a vehicle in its tracks. This is an example. This isn't an exact. This is an example of kind of what a Lidar would see in some situations, or what a mapping system would see. You're not going to have like a full city here, so it's just going to be in a 360-degree area around the vehicle. But this is the best thing I could get to kind of show off some of the sensors. The goal here behind this attack was very simple: stop the car by inputting fake data. My first idea was let's use image fracturing to create artifacts in both the Lidar and the camera array, like right here. If I could trick the camera into allowing me to make more artifacts, it would possibly kill the vehicle where it sits, or would do something stupid and crash. When I was able to do it, I was able to kill the vehicle where it sits. Attack-free spoofing fake autonomous vehicles into the grid. This is my funnest one, because this is the same principles that rely around the pedestrian spoofing. But this relies on more data communication channels. So here we're dealing with vehicle-to-vehicle communication, vehicle-to-infrastructure communication, and vehicle-to-pedestrian communication. So we want to first tell the vehicle behind us, there's a vehicle in front of you. This vehicle has identified a vehicle, relay that information. Then we want to make sure the grid knows that there's a vehicle here. If not everybody knows that this spoofed vehicle is there, it's not going to exist. Because somewhere along the line, a failsafe should, keyword should, catch it. Should is always the key word in this area here. Let me see. Yep, it's right here. So our goal here is to target the infrastructure. And we want to target everything from the satellite communication relationship to our vehicle, the vehicle to road communication ship, the vehicle to infrastructure, vehicle to pedestrian, the satellite systems, the RFID, the Wi-Fi. We want to make sure we can spoof this car down to as much of the science as we can, and then tell the autonomous vehicle behind us, there's a car in front of us, even though there isn't. So what I did was I took a script and I said, make a fake car next to a bicycle, drive it down the road. So I had a bike and pedestrian, he's riding his bike, and it was supposed to make a fake car right next to him. And it was supposed to tell the car behind him via the grid that there's a car right here. So what would happen was we'd get to a stoplight and the autonomous vehicle would just sit behind him. It wouldn't move forward because it thinks there's a car there, because the grid's telling him, and the bike is telling him, because vehicle to pedestrian, is telling him there's a car there. Well, all that guy would have to do is just stop, don't move, and now the vehicle's stuck. And then I tried to take this a step further. If we can do this one car, why can't we do this in more cars? Why can't we use this to piggyback and pivot and to make a much bigger mess? So then I started taking it, and I made one client, or one pedestrian, virtualized into more systems. So then he went off and virtualized into a few more boxes, and next thing you know, you have 30 fake cars and one real car, and the entire highway is done. That attack is actually, it's not as bad as you think, because it just relies on spoofing data and knowing where does the data go and what does it talk to. If you know if there is decision-making components in it, like prediction data, and there is check and balance data parameters involved, it makes it much harder. So let me see here. Yep, so here we go. So this is simulating an autonomous vehicle. This is what an autonomous vehicle will see in one of its examples here. We have things going on the side. This is its prediction line there. I want keep in mind prediction line. It's going to come back. But we can use a bike. We spoof the car. And our goal here is to not create a car in the environment, but to create a purple square. Your only job is to create a hitbox. If you create a hitbox, it believes there's a car. It believes there's a pedestrian. You don't have to go through the problems of creating anything crazy if you can create a hitbox. Then it takes out all the woe and the fuss of how do I do this, how do I do that. So next up, some special mentions, some things I would love to work on. Road-based denial of service. You could practically do it with the first few attacks. Data leaking / data exfiltration. There's a lot of consumer data involved in these programs. That's a lot of money there for certain individuals. API hijacking. Everything runs on an API. Autonomous vehicle ransomware. And this is something I really wanted to figure out how to get working and how to get running. Because if you could build a payload to deploy a ransomware to a vehicle locally, to the hardware on the vehicle, then you could turn around and create the next WannaCry, the WannaCar. WannaTraffic, we'll say. So what about autonomous vehicle hijacking? Well, it's not that easy. But my only way I figured out could be get us close to autonomous vehicle hijacking is by targeting the AI and using its AI against itself. Are we fairly familiar with AI here, kind of machine learning for the most part? So I'll quickly review it. Most cars work on some form of AI. They use either machine learning, generational learning. The algorithms are complex. I mean, we're dealing with an input node, a layer, to a second layer, decision layer, except for we're looking at thousands and thousands and thousands of these circles here when it makes a decision. But all these cars have to be trained. I wanted to find and show you an image where a company has a car on a turntable, and it shows where it's training it, and it gives the vehicle the ability to make decisions. I couldn't find the image, but it has it on a turntable with projectors, and it says, make your own choices. It was a safe environment where nothing can go wrong. You can inject variables that shouldn't exist. I haven't gotten very deep into AI manipulation, but my idea was, what if we could create a Stutnex for AI? What if we could create a system that we could slowly inject into the generational learning to pretty much break the generational learning? What if we could trick the car into slowly unlearning what we're teaching it? And in the same way that Stutnex magically broke some centrifuges. But the idea here was everything has to be trained. And this is an example of a car simulation engine that some training is done in. You can throw injector, mix some miscellaneous of things. But what if we could manipulate the AI? So I started thinking, where is it? There we go. We just have to then target manipulation of data. So then we have to know, how is the car trained? Well, here's a live training environment where we have 2 researcher engineers training, and we have a simulated environment. There's both. I have a pretty fun story about that for later if anyone's interested, where dinosaurs can break a car in a matter of seconds. It's weird. It's hard to explain, but it's interesting. So all we have to do is understand, how does it teach itself? Well, we know most cars are using generational learning. So how do we inject something into the car to trick it into slowly killing itself? Well, we just have to teach it to be a bad person. That's all we have to do. Pretty much, once you understand how the data is trained and where it's trained, if you can then corrupt the slowly generational, what's up?
You talk about pretty much the same kind of things like Inception.
Yes, yeah, pretty much, pretty much. But the whole idea is, if you can break the training cycle, you're going to break the generational cycle until they push a new generation. That was the big problem I ran across to when I was brainstorming. I says, all the developers have to do is just push a new training generation in, and everything you've done is gone. So it's kind of like the fail-safe that they have is, if they think something's wrong and they've noticed something's wrong, they just push a new training generation in, which is why you'd have to do it so gradually that you make sure that it gets into each one of the generations, from when it was a little baby car, its first steps, its first words, until it's on the road. So here's a little bit of other thing about this. I also thought, what if you can edit what if you can edit the, let me double check. I don't got the, prediction. Okay, that's different. So this is kind of an example of how digestion and projection on how some of these systems are trained. If anyone want to take a closer look at that, or I got another one here. It's a little bit better. Pretty much data comes in from the cloud and other resources, and then it's trained out. This is where I had a lot more success. All we have to do is manipulate the prediction, and we can do that by giving it false data. And if you feed it enough false data, you can make it think something's happening when it isn't. So here's an example of an Uber. This is Uber's platform for viewing their technology. And in yellow, pink is the prediction line. You can see here where this car is having some problems. It's trying to predict the car behind it. Well, it's doing this on live prediction data. So how about we just feed it some prediction data that's not real? And we just keep feeding it fake prediction data and hope that they didn't put in the time and the effort to put in fail-safes. I found that in my testing, if there were not proper fail-safes, I can trick the car into thinking pedestrians will do things, and you can send it just a number of fake data, and you can trick it into doing things it shouldn't. And that relied heavily on understanding the relationship between the prediction AI. Is it internal to the cloud, or is it to cloud to car? So now we're going to talk about SaaS. Cars have a lot of SaaS. So a lot of the car industry is treated as software as a service, sadly, and they're also treated as infrastructure as a service. But we're going to focus on SaaS. The reason that they treat the car industry as SaaS is because they believe the car industry is built on human interaction. It's built in the application. So if a customer pulls out their iPhone to go on the application, that's not hardware, that's software. It's talking to the cloud infrastructure, that's all software. But then they forget that the car is a hardware component mixed with software. And when you have a combination of business and devs that aren't agreeing, and the business will always take first hand, there's going to be a problem. But this is what I was told at a conversation was, everything needs to be made simple, easy to use, easy to expand on, open data as a platform, if that doesn't scare you, it should, and have a human focus. Let's see. So the way that companies want to deploy cars is they want to deploy them as an open source resource. They want to deploy data as a resource that each company can interact with. They want to deploy a pool, a central hub of data that they can all interact with. If that doesn't scare you, it should, because they're pulling data from devices like GPS data, everything, and it's all stored. Generational data is stored. That's your private data. That's privacy. That's stored and then traded among these companies for their training algorithms. And privacy is secondary. Security is often an afterthought, and SaaS creates a larger threat landscape when we're dealing with hardware that's not being addressed. It's just like having a network where you have all this fancy stuff, but you don't have a firewall. Everything needs an application for some reason, even if it doesn't. Every car company has an application, and they all have their external cloud structures, and all the cloud structures always need to be fed because they're hungry little monsters. I can say that firsthand. We place an internship had a cloud infrastructure that ran data prediction, and it ate data like it was candy, sugar. It was addicted to it. With so much data on the wire in the air, there's security controls and they go unseen and some gaps. If you really want to, you can make a whole talk into software as a service and its vulnerabilities. The biggest thing that I was told, I'm going to say that one for a minute. The biggest thing that really made me mad was when I was told that car companies in some cases are selling data to other car companies and buying data for generational training instead of on top of getting funding. And you got to ask, what is your business then? Are you a car company or are you selling data? Are you a service platform or are you a company that's a development and a service platform? So then that opens up the question for privacy standards in the industry as well. Really, the key thing I want you to take away with software as a service is they're treating cars as if they're a program. They're not treating it as if it's a combination of software and hardware that needs to be hardened together in a symbiotic relationship. So let's see. One of the biggest things they also use is think as a user. Think beyond the user. Like some sales pitch meeting, you know. Think beyond the user. Think about the group and not the single user. Well, when we forget about the single user does something stupid, then we deal with a BitLocker situation, and now the entire network is gone because someone plugged in a USB and hosed the entire LAN. And then they treat data as a platform, I said before. And finally, let's talk about resolution. So I had to find a way to put this in because it just made me giggle so much. But why haven't I talked about resolution? Well, it's very simple. I want to start a conversation. Most people don't think about the car industry when they think of security. They think they have their crap together, we hope. But what I wanted to kind of send people away with tonight is a question. A conversation starter. Let's talk about remedies. Let's talk about security. Let's talk about vulnerabilities. And let's get a conversation going that kind of forces the marketing and these head developers to kind of sit down and go, maybe I shouldn't program a bearer token hard-coded. That's it. Thank you. Any questions? Anything?
If you had a ton of money, would you buy and own a self-driving car?
Yes. Would I let it self-drive me? No, because I don't trust it. Would I let it? I don't. I've seen the horrors. I've seen the horrors of the Tesla. So Tesla just pushed a patch a while ago, a few months ago, where it it couldn't change lanes if the road was ending. So if there was a barrier here and it came here, it would just right into the barrier. It wouldn't switch lanes. They fixed that now, but the technology's not there yet, in my opinion.
So what about like construction zones?
Oh, that's actually great.
Construction zones.
So as in autonomous or self-driving?
Either.
Okay, so there's actually a really big push right now for autonomous snow plows. Through yeah, I know. We got to trust them now. Hey, I mean, I can't have my mailbox up for a week anyway, so I don't care. Yeah, well, an example of this is with Domino's. Their vehicle cannot operate in the rain. It can't operate in the snow. It can't operate in the fog because it relies on only a camera array. So the second that you throw in rain, the second that you throw in fog or smog or anything, if there's there was actually a problem where there's pebbles in the road, it can't drive. But back to your subject on construction vehicles, yeah, I think that there could be more of an application here than anything. I'm sorry, Kyle.
No, you're fine. I was just curious then, back to what we were kind of talking about before, as far as like the pure camera system where you were just saying about Domino's, what if like, some semi comes by, splashes a bunch of mud over the front of the vehicle can't see anything, or like we were saying before with like a laser, I mean, you can take a laser pointer and blast right through a camera and it'll be permanently blind.
Yep.
What if somebody were to set up a system just to blind every car coming down the freeway? I mean, what's that going to happen to the traffic going 70 miles an hour?
It should stop. It should stop. And that's the key word there, it should.
So like a bunch of mud being thrown on the front of the vehicle, it would just stop?
I can't tell you if it will or won't.
Okay, that's fine.
But it should stop. I've been told it does. They won't let me anywhere near it, I'm sure. All right, thank you guys. Anything else? Any questions? Also, I'm very new to speaking, so if anyone has any comments, any criticisms or things you would change, please let me know. I'm trying to improve.
Yeah, if you could fill out these forms, if you did, it would really help for the students as they go down the road and give more presentations. Because we're kind of new with this.
I was just going to say, as far as like just a general criticism, is that this is almost like a good thing. It's kind of a bad thing. Is that you have such a competency with a lot of this material that a lot of the things, acronyms and different kind of things you're talking about, you kind of take for granted.
I wish I had more time
to go through. But other than that, I think it was an awesome talk, and I think you should definitely do another talk just because I thoroughly enjoyed it.
I wish I had 2 hours to really go in depth on some of this stuff. But.
Yeah.
I'm also looking for an internship, by the way.
It is.
Zach, as you get this down and you get it working, why don't you invite them to the class when you give your whole presentation? They'd like to come.
It'll probably be the same thing, except for I might have the demos ready.
If you got the demos and stuff that you couldn't see, you're welcome to let them know to walk into the classroom. If you'd like to come and sit in on any of the talks that they're giving.
You brought up cameras real quick. I just want to make a note on the Uber vehicle here. This does rely on multiple things other than cameras, but if you knock out that camera array, that thing's dead. It relies on a combination of everything. So you knock out those cameras, it's dead in the water most of the time.
What will it do if it's going high speed and the camera dies?
It should slam on the brake. But then
Slam on the brake.
most of the time,
Michigan and it's 20 degrees below zero and you're going 70 down the highway and it decides to slam on the brake.
The car's gonna go sideways and cause a bunch of accidents.
Yeah, like I know
when that's turned off, I'll tell you some stories. Thank you.
Just like every other Michigan car.
And that's a wrap for us at Zach Jackson.